Hey, what's up guys? My name is Cherno. Welcome back to my C++ series. So today we're going to be talking all about precompiled headers in C++. We're going to first of all start off by just talking about them, what they are, and why you should be using them. And then after that, we're going to jump into both Visual Studio and GCC, G++, and kind of take a look at a real-world example of how to actually set them up and see the actual benefits in a very simple example. Okay, so first of all, what are precompiled headers? I'm sure that if you've been using C++ for any kind of moderate amount of time, you've probably heard of them, but I would place a fair bet that a lot of you probably aren't using them because really, they're not really required to be used. They're something that is probably quite vital for larger projects, but for most of you who are kind of still learning, you probably don't have massive projects in which you would really need to use C++. And if you haven't actually worked somewhere or worked on a large project, then you probably would never have really set this up by yourself unless someone's explicitly kind of told you, hey, you should start using precompiled headers. So there's a good kind of bet that I think a lot of you guys aren't using them, but you need to use them. They will kind of help you out so much. What precompiled headers actually do is they give you an opportunity to grab a bunch of header files and convert them into essentially a kind of compiled format that the compiler can then use instead of having to read those header files over and over again. So here's an example, right? I use the standard template library quite a lot, right? I might be using vector, I might be using string, I might be using other things in the standard library like, stdc out. All of those kind of files, right? Especially the standard template library comes from header files, right? They're made out of header files because they're templates. They have to be defined in header files. Now, every time that I include vector, let's just use that as an example. Every time I include vector in one of my C++ files, it needs to read that entire vector header file and compile it. Not only that, but vector includes a bunch of other include files, right? That needs to happen as well. The preprocessor has to go in, copy all of that into that vector file. Essentially, you end up with something that's probably around 100,000 lines of code or so that needs to be parsed, tokenized, and compiled in some form before you actually get into your main kind of file that you're trying to compile. Because if your main file includes vector, then vector has to be copied and pasted into that main file. And then that whole kind of conglomerate of code, that whole mass of code, has to be parsed and compiled every time. If you suddenly decide, I'm going to change my main kind of file that I'm trying to compile a little bit, and by main file, I just mean a C++ file, right? It's just the one that we're kind of working on right now. Because if you have many C++ files in your project, many places that include vector, obviously they're going to be individually included in every single file, right? Because that's how the compiler works. Every translation unit is compiled separately, and then later the link kind of links all of that together. If you're unfamiliar with that, definitely check out the video on how kind of C++ works and how the compiler works and how the linker works, all that kind of stuff. Anyway, the point is, every time you make a change in that C++ file, the whole thing has to be recompiled, right? So that vector class, that vector file has to be copied and pasted into your C++ file, parsed all over again from scratch, and compiled again because you've, added a blank line or something like that, right? What that means is that your compile times are going to be a lot longer than they potentially could be. Not only that, but think about the fact of you have multiple C++ files in your project. They all include vector, right? Well, suddenly you have to keep parsing that same code all over again every single time for each translation unit, for each Cpp file that you're actually trying to compile. That takes time. So what you can do instead is use something called a precompiled header. What that does is it takes a bunch of header files which you tell it to take in, right? A bunch of code essentially, and it compiles it once, and it stores it in a binary format that is way faster for the compiler to actually deal with than just text, because it's already in a parsed kind of state, and it's in binary, not text, right? That's ready to go, and every time you include that precompiled header file, it already has everything you need. That's it, right? So instead of it parsing that entire vector file every single time, it only needs to look at the precompiled header, which is already in a great, fast, easy to use binary format, easy to use for the compiler that is. Binary format, right, which it just takes every time you need vector because you've included your precompiled header in your source file that you're currently compiling, and all the data's there. And what that means is that it results in way, way, way faster compilation times, okay? Your projects will be compiled like many times faster. because of this, especially as your kind of project size, I guess, grows and you end up having more and more C++ files, more and more header files, all of that stuff, and you can keep shoving in more stuff into the precompiled header, and also you have more source files which need compiling that use common headers. It's just going to be exponentially faster. It's going to be so much better. So you need to use precompiled headers if you care about compilation times. If you see that your compilation times are getting out of hand and it's taking like a minute to compile, you could potentially reduce that to like 8 seconds if you just kind of start using precompiled headers. Okay, so I've talked about the greatness of precompiled headers, and we're going to go ahead and take a look at an example in a minute, but I also want to talk about what not to do with precompiled headers. So what I've mentioned so far, kind of, as to what a precompiled header actually is it's essentially a header file which includes a bunch of other header files, right? So because of that, a lot of people might be like, okay, well, I can just put everything in my project into that PCH, into that precompiled header. And if I do that, then, well, I'll get really fast build times, right? Well, yes, but if you put stuff in your precompiled header which changes, so stuff in your actual project that you're likely to change because you're working on your project, obviously the precompiled header has to be rebuilt. And that takes time, right? That could potentially end up slowing down your compilation. So do not put frequently changing files into that precompiled header. Really what it should be used for, there's nothing wrong with you putting kind of your own project files into there. Like, if I have something like a log.h file, which doesn't really change because how often do I touch my own logging library, right? I kind of written that once, it's not like I have to keep adding stuff to it. That's fine. You can put that into your precompiled header because that's something that, first of all, is needed a lot, right? Which also makes it convenient to use because since you're including your precompiled header in every single source file now, right? You also have access to those logging functions. So that's really kind of easy to use now. Now it's kind of, it makes it more convenient because you don't need to manually include log in every single Cpp file that you have in your project because you're including the precompiled header which includes log. So that's good because it adds convenience, right? But also, I've made sure that I'm not doing it if I'm going to be changing, if I'm currently working on my logging library, probably shouldn't be in the compiled header, in the precompiled header, right? Because every time I change that log.h header file, it needs to get recompiled into the recompiled header, which means the whole precompiled header, I might have said recompiled header, the whole precompiled header has to be rebuilt from scratch every single time. So don't put stuff like that in it. What it's really used for is probably like external, I would say external dependencies, or there's a bit of an issue with dependencies as we'll talk about in a minute, but essentially it's used for it's vitally used for code that isn't yours. So for example, the STL, right? Code that is in the standard template library or in the standard kind of C++ library, or like the Windows API, like if you want to include windows.h, that is a massive header file which includes a billion other header files, right? You're not going to be modifying windows.h, you're not going to be modifying the standard template library, right? So there is no reason for it to kind of not be in a precompiled header file, right? It should be there because that is a lot of code, probably many times more code than your actual application, right? And when you think about it, what's your application made out of? C++ library, standard template library, Windows API calls, that kind of stuff, right? That's what it's made out of. It uses that stuff all the time, and that's code that you're never going to be touching. So put all of that into your precompiled header, right? That stuff belongs there because that is a lot of code, probably many times more code than your actual application, than your actual project, right? You're compiling that every single time per CPP file. That's terrible. Put it into a precompiled header where it can just be left alone, and you'll get the benefit of, first of all, getting access to everything in every CPP file, right? You won't need to actually include like memory, for example, if you want to use smart pointers, or include vector all the time because it's going to be in the PCH, which will be included in every single C++ file that you actually write. So you'll have access to that. It's convenient and it will speed everything up really quickly. Now I did say something about dependencies. One thing that the PCH can actually do is because you shove everything into your PCH, it can potentially hide what's actually being used. Now, it's theoretically speaking, if I write a CPP file that uses like, I don't know, a window library or something, right? And I put that windowing library into my PCH, it's not really apparently clear. If you read that CPP file, you don't actually know what it needs. It might need GLFW, a windowing library. It might not need, it might need like some other dependencies, but because all of your dependencies are in the PCH, if you just isolate that CPP file and you take it, you don't actually know what it needs. And it can be very difficult in terms of modularity and code reuse for you to actually be like, okay, well now I can take this file, put it into another project. Wait, I have no idea what it needs, right? If you just had include glfw or something in that actual header file, in your actual CPP file that you've taken, it would be very clear, wouldn't it, that this file needs this file, right? But if you have just include PCH and then a bunch of includes in that PCH, it can kind of make it a little bit harder. So that's what a lot of people kind of mention when they're dealing with precompiled headers, that, be careful, maybe don't include all dependencies there because it'll make it clearer and easier to read if you actually include your dependencies per kind of file that needs them. And I agree with that to an extent. Depends how kind of specific that dependency is. If you're making a game engine and you want to include glfw, in your PCH, I mean, you can, but on the other hand, think about how many actual source files need that. Not that many, right? Probably, like, if you've written a game engine, quote unquote, properly, probably only one CPP file actually needs to include glfw, right? Because everything else will kind of be abstracted and in your own API. So in that case, well, why put glfw into your precompiled header? You can, it's not gonna make anything worse, right? Probably. However, it does probably hurt readability a bit, and also it'll be extra stuff for your precompiled header to compile that really only one CPP file needs. Stuff that you should put in there, as I mentioned, is like STL, right? Because strings or vectors or standard cout might be something that you broadly want in a lot of places, right? And stuff that you don't want to keep recompiling from scratch every time. glfw, on the other hand, kind of something you can probably compile once and you're done. So that's kind of the idea of precompiled headers. I've talked a lot about this whole thing. Let's jump into it and take a look at a few examples, and we'll also kind of measure how long it takes to build using precompiled headers and not using precompiled headers. So what we've kind of got here is a very simple hello world application. It says hello world, right? However, it includes this file which I've named pch.h. Now, precompiled header is kind of what I've called it. Can be called absolutely anything. Visual Studio by default makes something called stdafx.h if you kind of use the C++ wizard to actually create a project, or you kind of create a project from a template. I usually create empty projects, which doesn't have any of that, but this file can be called anything you want it to be called. And right now, even though it's called pch.h, don't be fooled, we're not using precompiled headers in this project. What I'm doing is I'm simply including, in my pch, I've just got a header file, which includes a bunch of other header files. It includes some basic kind of C++ library stuff. It includes some data structures, as well as the Windows API, so windows.h, right? This is a lot of code, right? I probably don't need to tell you that it's a lot of code. If I, just for fun, go ahead and say, give me the preprocessor output. So if I go to preprocessor and then preprocess to a file, if I shut that on, and then I just hit Control F7 to build this file, and I take a look at what is actually in this main.i file, if we scroll down to the very bottom, you can see that, I mean, here's our kind of cout hello world. It's like 370,000 lines of code. That's a lot of stuff, right? That is what will be recompiled every single time you include this in your actual CPP files, right? In every single CPP file individually, it has to go over and process 370,000 lines of source code, and then tokenize them, and then compile them, and then do all of that stuff, right? Every single time. We want to avoid that. So what we can do is actually use precompiled headers. So I can turn this into a precompiled header. This is a pretty good example of what you might have in your PCH, right? I haven't got any kind of, I mean, this is just a hello world program. So of course I don't have my own kind of massive set of code, but really I'm just including stuff that I know I'll never touch and stuff that is likely going to be needed by this kind of program. So what I'm going to do is, first of all, once you have your header file, make a CPP file which includes your header file. This is Visual Studio's way of doing things. We're going to take a look at what G++ actually needs. And Clang is very similar to GCC as well. But what we need to do for Visual Studio is actually create a CPP file which includes our header file, right? And then on that CPP file, we need to right-click, hit Properties, and then go under C++, we need to go to precompiled headers, and then select our precompiled header, to be create, right? So for this specific pch.cpp file, we're going to create a precompiled header and then hit OK. Then I'm going to go to the entire properties for the entire project, right? The properties for the entire project. And I'm going to under C++ precompiled headers, select this to be use. So our entire project now uses precompiled headers. And then the precompiled header file that we will use will be, of course, pch.h. Okay, hit OK. Now this, of course, will apply to everything. So if I now look at the properties for main.cpp as an example, you can see it's set to use our precompiled headers, and then it includes, and then it specifies which one is used, and then this is what it will actually compile to, right? So this is the output file. This is the compiled binary format of our actual precompiled header. And then because we've set that for the project, it applies to everything. So in summary, set the project to use your precompiled headers and specify which one is used. And then for your CPP file, which includes pch.h, set it to create precompiled header. And that's all you need to do. Okay. So now if I just right click build, you can see we should build successfully and everything should be fine. That's how we create PCHs. Now let's take a look at how much that actually sped up our compile time. Now keep in mind, this is a very basic project, which should be even more kind of impactful because you can see that we really don't have anything here. We've only got one CPP file even. But if we right click, go to properties, and then just disable this for now, so not using precompiled headers, we'll kind of get an easy kind of comparison to the before state. So what I'll do is under tools options, under projects and solutions, VC++ project settings, I'm going to set build timing to yes, just so that it times how long our build takes. And then I'm just going to clean this and then build it. And we'll take a look at how long that takes. Okay, so that actually failed because it can't open main.obj for some reason. I'm just going to go to properties and make sure, because I did the preprocess to a file, I'll just make sure that's set to no. And then I'm going to clean this project and then I'm going to build the project. Okay, so you can see building the project, a clean build, took 3.3 seconds, right? And then if I edit the source file, for example, let's just print hello world twice, and I build that again, you can see that a subsequent build takes about 1.5 seconds, right? And let's just do that again just for fun to make sure that we get a more reliable timing. There we go, 1.5 seconds, right? Okay, cool. So now let's just switch this precompiled headers thing to use. And then I'm going to, again, clean it. We're going to see how long a clean build takes. Okay, about 2 seconds. So that's, I mean, it was 3.3 seconds before, so that's considerably faster. And now let's edit this source file and just duplicate that line. Look at that, half a second. Okay, so down from 1.5 seconds to half a second. That's 3 times faster. And we can remove this and try it again just to make sure. And there you go. You can see just how much faster using precompiled headers actually made this compilation. And this project is absolutely tiny. Cool, so let's take a look at how we might do this in G++ and we'll also kind of time that. So the first thing I'll do is I'm just in the source directory here, which has these 3 files. All I'm going to do first of all is just see how long it takes to compile this project without using precompiled headers. So if I just go ahead and write time, G++, and then we're using C++11 for this, and then just main.cpp, I'll try and compile that, see how long it takes. There we go, 1.5 seconds. I'll go and like modify the source file again by just adding another line, and then we'll see how long this takes. Okay, about 1.5 seconds, right? Cool. So now let's go ahead and actually create a precompiled header. So I do that by basically just compiling that pch.h file. That's all you need to do in GCC. So I'll hit enter. You can see it takes a little bit of time, and then what it generates is this pch.h.gch. Now, first of all, look at how big it is. 114 megabytes. That's quite large. Second of all, though, let's go ahead and we'll delete a.exe just so it's basically a clean build. And then we'll go ahead and run this again. Look at that, 0.28 seconds, right? If I go ahead and remove this again and do another compilation, whoops. Let me just do a clean thing here. 0.2 seconds, right? About 0.3 seconds, let's just round up. You can see that it's down from 1.5 seconds to 0.3 seconds. So much faster. That's like 5 times faster. Okay, so hopefully all of these examples have kind of shed some light onto why you should be using precompiled headers. They speed up your build times a lot, and they also make it more convenient to actually write code since you don't have to keep including commonly used header files over and over again. I hope that made sense. Let me know in the comments below if you've been using precompiled headers, if this is the first time you've heard of it, if you think that this is something that you should use, or kind of your experience with them. In general, every software project should be using precompiled headers. There's no real kind of, should I use them, should I not? Every project should be using them. What to put into your precompiled header is a different story, and we've covered a few of the kind of good examples of what you should put in there, but whether or not you should be using them, yes, absolutely. Unless you're making a little sandbox project and you don't want to go through the hassle of setting it up, not that it's particularly hard, then yeah, I probably would avoid that, but otherwise, you should be using precompiled headers. Hope you guys enjoyed this video. If you did, you can hit the like button. You can help support this series and everything that I do here on this channel by going to patreon.com/the Cherno. You'll get videos early, as well as access to cool kind of source code development repositories and many other cool rewards, and it does help me make more of these videos. Hope you guys enjoyed this. Leave some comments below as to what you want to see next in the C++ series. I'll probably be kind of, since I'm focusing a lot on the game engine series, I'll be kind of making videos to do with that probably. Standalone C++ videos based on topics that we cover there. But also that game engine series is a really good example to see all of these kind of concepts that we've been learning in the C++ series actually come together. So definitely check that out. I will see you guys next time. Goodbye.